Welcome back, everyone. In today's Technical Explainer, we are setting the stage for a massive deep dive into the absolute next leap in human-machine evolution. We're going to unpack exactly what collaborative robots, or cobots, actually are, how they work under the hood, and why they're completely upending modern manufacturing. If you're fascinated by automation, or maybe you're looking to build a career in robotics, well, you're in exactly the right place. Let's get into it. Okay, so let's dive into this. For decades, if you walked on any factory floor, the rule's pretty simple, right? Robots stay inside their heavy metal safety cages, and humans stay out. Traditional robots are super powerful, but they're basically blind to us. If you step in their way, they do not stop. Which brings up a really massive question. How do we break those cages? How do we actually create an environment where a human and a robot can stand shoulder to shoulder, working on the exact same assembly line completely safely? So to answer that, here's our quick roadmap for this explainer. First, we'll officially meet the cobot, compare it to those traditional industrial robots, look at its anatomy, check out the built-in safety benefits, run through some real-world applications, and finally, talk about Industry 4.0 and what this all means for your future. All right, Section 1, Meet the Collaborative Robot, the new era of automation. So, by definition, a collaborative robot, or cobot, is a modern machine that's purpose-built to safely interact, assist, and work right alongside humans in a shared workspace. Think about why these were even created in the first place. The goal was never to replace us humans. Actually, scratch that. It's more like the goal was to bridge the gap between human ingenuity, our ability to problem solve and adapt, and robotic efficiency. They're your assistants. In fact, a lot of these things weigh less than a standard piece of carry-on luggage. They're just designed to easily take over the dull, dirty, or dangerous tasks so you can focus on the complex stuff. Moving on to Section 2, Cobots versus Industrial Robots, or as I like to call it, breaking the cage. And this brilliantly illustrates the difference, because the contrast out on the factory floor is literally night and day. On one side, you've got traditional industrial robots. They're heavy, they absolutely require those massive safety cages, and honestly, they're notoriously inflexible and hard to program. Once you bolt them down, that's it, they stay there. But on the flip side, we have the cobots. They're cage-free and highly safe. And because they're so lightweight, you can just easily roll them around to different parts of the factory. Plus, they offer incredibly fast installation and super easy programming. Sometimes, you can literally just physically guide the robot arm through the exact motions you want it to learn. How cool is that? Okay, let's peel the onion a bit in Section 3, Anatomy and Working Principles under the hood. So how do these machines actually pull this off? Well, looking at the physical components, you've got the secure robot base and the robot arm, which is powered by highly precise servo motors at every single joint. But the real magic happens right at the end of the arm, with the end effector, or the gripper, which actually handles the product. What makes a cobot uniquely capable, though, are the vision cameras and the force and torque sensors. These sensors give the machine a sense of feeling and sight. It can physically sense resistance if it bumps into something, which, as you can imagine, is an absolute game changer. But, that physical arm is pretty much useless without a brain. The robot controller acts as the central nervous system, and it's usually integrated with a PLC, a programmable logic controller, and an HMI, which is the screen you'd use to control it. Add in advanced safety sensors, artificial intelligence software to really optimize those movements, and IoT, the Industrial Internet of Things, which basically lets the cobot talk over the network with other machines in real time. It's the whole shebang. Which brings us to Section 4, Built-in Safety and Benefits, Working Without Fear. The absolute most crucial point here is exactly what happens when a cobot accidentally bumps into a human operator. Step 1 is collision detection. Those sensors we just talked about instantly recognize an unexpected impact. Step 2 is force limiting. The motors are literally designed so they physically cannot exert enough force to crush or severely injure you. And Step 3 involves constant speed monitoring and safe motion control. So if a human enters a designated zone, the cobot just automatically slows down. And if contact is actually made, it triggers an immediate millisecond emergency stop. You literally just tap it and it freezes. No harm done. Now, of course, every system involves some trade-offs. The pros of a cobot are huge: high production yield, maximum safety alongside humans, incredible precision, way fewer human errors, and that awesome flexibility we discussed. But the cons, well, they're kind of rooted in physics. Because they have to be force limited to stay safe, cobots have payload limitations. They can't lift massively heavy car chassis like those big traditional robots can. They're way more suited for, say, assembling the delicate electronics inside the dashboard. And again, for safety reasons, their operating speeds are generally going to be a bit slower. Let's look at Section 5, Real-World Industry Applications, Cobots on the Floor. Now, what's really interesting about this is the sheer breadth of applications right now. In the automobile and electronics sectors, cobots are being used for super precise assembly, safe welding, and repetitive screw tightening. Over in food, beverage, and pharma, they handle delicate packaging, rapid pick-and-place sorting, and quality control. And in medical devices and logistics, they are totally revolutionizing things, from lab automation and testing to warehouse material handling and machine tending. They're everywhere. But keep in mind, a cobot doesn't just work alone on an island. The ultimate sync happens when you fully integrate a cobot into the factory's nervous system. By connecting the cobot to PLCs, HMIs, and SCADA systems, and then layering that with AI and IIoT connectivity, factory managers get real-time data monitoring. It's like a giant puzzle coming together. The cobot talks to the conveyor belt talks to the quality control camera, and the entire factory just optimizes itself on the fly. And that perfectly sets up Section 6, Industry 4.0 and your future, the next step in evolution. We are moving way beyond just isolated automation at this point. We're fully in the era of Industry 4.0. And cobots are quite literally the heartbeat of it all. They're the physical building blocks that transform a standard, rigid manufacturing setup into a highly efficient, AI-driven smart factory. They really represent this whole new world where data and physical robotics blend seamlessly to maximize output while always prioritizing human safety. So what does all this actually mean for your engineering career? Well, it means massive, undeniable opportunity. The industry is practically desperate for skilled professionals who understand this tech. We're talking soaring demand for robotics engineers, PLC programmers, automation engineers, forward-thinking technicians, electricians, and specialized cobot programmers. Seriously, learning this technology is basically future-proofing your entire career in manufacturing. And if you're sitting there wondering how to take that next step and truly master these systems, well, that's exactly where our sponsor for this explainer comes in. You can empower your entire automation journey with the experts at DEVI Automation Solutions. DEVI Automation Solutions is an absolute powerhouse in this space. They provide comprehensive services spanning basically everything we just talked about today. Industrial automation, PLC, HMI and SCADA development, VFD drives, artificial intelligence, and IIoT integrations. But they even go beyond the factory floor, offering expertise in smart agriculture, home automation, and solar solutions. If you need a partner to upgrade your facility or just want to build your own automation skill set, you can reach out to them directly at deviaautomationsolutions@gmail.com. Which brings us to the end of today's deep dive. But before we wrap up, I want to leave you with a quick question. With technology moving this incredibly fast, what specific automation or robotics topic should we explore in our next technical explainer? Let us know down in the comments. If you found this breakdown valuable, please hit that like button, share this with your fellow engineers and students, and make sure you subscribe and hit the bell icon so you never miss out on the future of technology. Keep learning, keep innovating, and we'll see you in the next one.